So here is your law of sines, law of cosines, Heron's formula video notes. This is just some of the basics. I have a couple other videos that we will see that will go into a little bit more detail as far as something called the ambiguous case that you'll see on your notes. But here are just some of the basics. So law of sines, it's a nice way to find some sides and angles of triangles when you're missing them. This works in non-right triangles. And so that's different from like our basic sine, cosine, tangent where it has to be a right triangle. And this does not. And so we can find some unknown sides or angles depending on what we need. Something to keep note of is what the information is that you're given. So for instance, on this one, we have this angle, and this side of 8 that's given. So as I'm looking at this, I see, if I'm going back to my days of geometry, this is kind of like an angle, side type of a triangle, type of the given information. Okay, and I say that because it'll be important as we progress and we're trying to solve different problems. We're going to want to know what information we have. It will help determine if we use law of sines or cosines. So we right now have angle, side. That is a good one to use for the law of sines. And what we're going to do here is, as you're looking at the formula, you're only ever going to use 2 of these at once, right? So maybe something like this, or maybe something like this. But you're only ever going to use 2 of them at once. And you always want the side and the angle opposite. So like this is angle A, this is side A. Angle B, side B. Angle C, side C. Okay? So when we are doing the law of sines, I always look at opposites and I pair them. So for instance, I could say sine of 36 over 8, because these are the opposites. And I could set that equal to these 2 opposites, sine 48 over b. Now, the only reason I wouldn't set it equal to these 2 opposites is because I would have 2 unknowns. Both the side and the angle are unknown. So as always, you only want 1 unknown. Okay, and then we're going to solve. So we're going to cross multiply. We have b times sine of 36 is equal to 8 times sine of 48. We're going to divide through by the sine of 36. So now we have b, and this is the value for side b. And you can enter this all into your calculator just like that. So we have this value for the length of b, which is the side, is 10.11. Okay, so over here we have 10.11. Now, in order to find c, one of the c's, we need one of the other ones first. So I can find the angle much easier. I know in a triangle there's 180 degrees. And if I remove the 2 given angles, what I'm going to have left is 96. And so now I found the measure of angle C. Okay, so now that I know the measure of angle C, I know that this is 96. Now I can do another one of the law of sines, and I can go through and state one of these ratios. So I'm going to use the same given information, so sine of 36 over 8. And then I'm going to do that for C, sine of 96 over C. And we'll cross multiply again. So I have C times sine of 36 is equal to 8 times sine of 96. We're going to get C by itself. So we're going to divide through. And so now I have C is equal to, and again, I can plug this all into the calculator because this is just a side that we're looking for. It turns out to be about 13.54. Okay, and so now the question said solve. Anytime you see solve, that means find all of the missing angles and missing sides. We have them all. So I have all 3 angles labeled. I have all 3 sides labeled. Okay, so that's a basic law of sines. Okay, we're going to take a look at a law of cosines, a basic law of cosines. So there are a couple of different ways that you could do law of cosines, and I didn't tell you on law of sines. Maybe I should go back and tell you that. You can not only use this on angle, side, you can also use law of sines on the famous side angle case. That's where it gets fun. That's where we have more than one triangle, perhaps, sometimes no triangles, but I have a whole video on that. Okay. When you are into law of cosines, The way that you would be using this is you're either going to be using the side angle side case or the side side side. Okay, so those are the two that we want to think about. I know it says here both can be used in the side side angle case, but we have to remember that there may be 0, 1, or 2 triangles. I would probably always tell you, if we have a side side angle case, try the law of sines first. That would be my rule of thumb. So I would say law of sines first. Okay, so we have no picture this time. I'm going to draw a picture so that I know what I have. I'm going to label it, make sure I've labeled my triangle, and then we can see how this is going to look like a side angle side case. So here's my triangle A, B, C. We're given little a, so that's the side opposite angle A, so there's 11. Little b, so find angle B, go over, there's 5. And then angle C, big C, if it doesn't have an angle in front, capital letters always stand for the angles, so there's your 20 degrees. So now I can see this is a side angle side case. Okay, so again, it's saying that we have to find all 6 parts. Solve meaning find all 6 parts. So in your law of cosines, okay, notice I always take a look at this. The side and the angle that are opposite each other are always like the bookends of the formula. So side B, angle B, side C, angle C, they're bookends of the formula. So I want to identify the angle that I have. In this case, I have angle C, which means side C over here would be the bookend of my formula. So I'd kind of be using something like this. Okay, they're all interchangeable. They all really mean the same thing. But for now, if you're just getting started, let's focus in on this. So side C, I don't know. So I'm going to start and I say I don't know you. But I know A is 11. So I have 11 squared. B is 5 squared. And it says minus 2AB. So 2 times 11 times 5. And then we have the cosine of the angle, which is 20. Okay. The nice thing with this, notice I have every single value that I need over here. My unknown's on the other side of the equation. You can plug that all into your calculator. All one string into your calculator. And when you do, you're going to get 42.6338. Okay, so now we have to find C, so I'm going to have to square root that. And if we square root that now, we find C is about 6.53. Okay, so we have a side right now. So we have side C. Okay, I'm going to label it so I can see this on our triangle. And now what we need to do is we need to find the other 2 angles because all 3 sides are filled, and now we need to find the other 2 angles. So at this point, you can pick whichever angle you want to solve for because each angle, I have a side opposite. There's my angle, I have a side opposite, so it doesn't really matter. Maybe let's go for A. So if I work with A, that's the angle, so that's my unknown. This is the side opposite, that's going to be the side that's set by itself, that's the bookend. So I have 11 squared, that's by itself. Now the other 2, doesn't really matter how I plug them in the formula. So I have one side plus the other side. Now the other side that we have is that 6.53 that we just solved for, squared. Okay, so then we have minus 2 times 5 times 6.53, and then the cosine of A. So notice here's your unknown. Okay, we're going to simplify. So I have 121 when I squared that is equal to 25. This is going to be about 42.6338 minus. Now all of these can be multiplied together because they're all attached. Okay, so I have 65.3 cosine of A. One big thing here is 65.3 and cosine, they are attached by multiplication. I cannot combine this with the 42 and the 25. Okay, this is attached to cosine. It does not go to these 2. That's one of the biggest places where people make mistakes, so please be careful. What I can do is I can subtract the 25 and I can subtract that 42.6338. So now this, on this side, all I have is negative 65.3 cosine of A. Over here, when I subtract those, I'm left with about 53.3662. Okay, watch your negative. That was a negative. Don't forget to bring your negative down. So we're going to solve for cosine of A. So I'm going to divide by 65.3. And that's a negative 65.3. And so now I have cosine of A. And I have about negative 0.8172 when we plug that in. And so to get angle A, I now have to do the inverse, right? So we're going to type inverse cosine of that angle. And I'm going to find the measure of angle A. Turns out to be about 144.8. Okay, so over here I have about 144.8. And then the very last thing we have to find is measure of angle B. And we're going to use the fact that a triangle has 180 degrees. So remove the 20 that was given, remove the 144.8 that we just solved for, and we're going to have left angle B. Angle B is going to be somewhere around 15 point, we'll say 2 if we round it. Okay, and so there is everything. So we have all three angles, we have all three sides, we have solved our triangle. So that's, again, a basic sample of law of cosines. Okay, and then we have two different area of a triangle formulas. So this one, nice, very simple, law of sines kind of area of a triangle formula. And again, they've given you like 3 different ways that you can look at it. I typically say to myself the area of the triangle is 1/2 AB sine C. That works for me, okay? Notice what we have here, 2 sides, 1 angle. Okay, so when I'm looking at this type of a setup, this to me looks like a side angle side setup when you're using that. So again, just ways to kind of organize this in your head. All right, we're going to try an application problem. So we're going to find the area of a regular octagon. Regular meaning all sides and all angles are equal. Inscribed, so that means all the points, all the vertex are touching the circles. Inscribed in a circle of a radius of 9 inches. So if I had a center point and I drew out a radius, that would be 9. If I drew out a radius here, that would be 9. Okay. So looking at this triangle, I know that this is an isosceles triangle. Something to keep in mind. What I need to do, because it says find triangles and their vertex angles. So if this is isosceles, I'm looking for that vertex angle. So because it's an octagon, I could draw 8 total triangles within this octagon just like I did this, which would mean all of these angles going all the way around, if I were to add them up, would be a total of 360. So I had 360 degrees with 8 of those individual angles. That's going to get me an angle here of 45. Okay, so now I have a triangle. And if I'm looking, it says we just have to find the area. Have to find the area of a regular octagon. Okay, well, if I could find the area of one of these triangles, I know that all of these triangles are going to be equal. So then I would just have to multiply it by 8 when I'm done. All right, let's start by finding the area of the triangle. So the area of that triangle, we said we're going to use that formula 1/2 AB sine C. All right, well, if I were to label this triangle, I could call this A, I could call this B, and I could call this C. So notice how this is side A, side B, angle C. Here's your side, angle, side case. Okay, so I have 1/2 9 times 9 times the sine of 45. Nice and easy. You can plug and chug that right into your calculator. That gets you about 28.6378. And because it's area and we're dealing with inches, I could say inches squared. Okay, but that's for one triangle. So that's the area of one triangle. We want the area of an octagon. So the area of the octagon is taking basically the area of this triangle and multiplying it by 8, since I would be able to produce 8 individual triangles within that octagon. And when we do that, we're going to get 229.1026. And again, it's area, so I could say inches squared. So your final answer on this is about 229.1026 inches squared. It doesn't tell you where to round. Rule of thumb is typically as long as you're rounding correctly. If it doesn't tell you where to round, then as long as you round correctly, you should be good. Okay, and our last one, a different way to find the area of a triangle. This is used when you have three sides that are given. So this is that side, side, side case, which not only can be used when you're doing this formula, but also side, side, side you can use for the law of cosines. So something we have to find is what's called the semi-perimeter. The semi-perimeter is saying take all of the sides, add it up, and divide it by 2. That's the S of this formula. The A, the B, the C, those are the three sides that are given to you. Okay, so we're going to start by finding the semi-perimeter. So I'm going to add up the sides. So I have 13 plus 15 plus 18, and I'm going to divide that by 2. So 13 plus 15 plus 18, I get 46. 46 divided by 2, that's going to get me 23. So now that's that S of the formula. So if we go into the formula and plug that in, so I have 23, then I have 23 minus one of the sides, times 23 minus another side, times 23 minus the third side. I would always tell you, take it step at a time, show me your work. If you don't show me work and you make a mistake, it's hard to give you partial credit. So I would go through and I would subtract out each of these so I can see what all of those values are. I would also tell you, it's not a bad idea to, again, take one more tiny little step, show me this work, multiply that out. And then the very last thing to find the area is actually take the square root. And when you take the square root of that, you're going to get about 95.92. And we could say here units squared, since again, that's going to be the area. Okay, so that was just a little introduction. We're going to get into a little bit more. I have other videos coming up for some of the other notes that you're going to be working on. If you have questions, don't forget to send me an email or a text. Have a great day.